A soccer player kicks a ball from the ground with initial speed v0 at an angle theta towards a vertical barrier. The ball hits a barrier exactly at the maximum height, rebounds at the same speed, and lands back at the starting point. What is the horizontal distance from the kick points to the barrier? So for this is a very typical kinematic question. So for this type of question, we have to figure out what type of motion the ball is doing. So first, let's draw a free body diagram. This is a ball. The only force that acts on it is gravitational force, which means it is doing free fall. And then the ball is moving with an initial speed v0 at angle theta towards the vertical barrier. So let's draw v0 and angle theta. This is v0. So that which means we can figure out the vertical components and the horizontal components of the v0 using trigonometric ratio. The vertical component is v0 times sine theta, and the horizontal component is v0 times cosine theta. Let's look at the free body diagram. The only force that acts on it is gravitational force, right? And then there's no components or no external factors horizontally that affect the ball, which means its motion horizontally will never change in this question. Which means the v0 times cosine theta, which is its horizontal components, will never change. It will stays the same in this question until it hits a barrier. So let's keep it there. Let's look back to the question and see what it is asking you. It's asking you what is the horizontal distance from the kick points to the barrier. For displacement or horizontal distance, we will use a formula x equals v0 t plus half at squared. We already knew the horizontal components, which is v0 times cosine theta, would never change, which means a horizontally is equal to 0. But this is 0, so we can cancel it out. So the displacement is only x equals v0 horizontally times t. So we still need to figure out what is t. How do you figure out t? Due to the free fall and subject to the gravitational acceleration, its vertical components v0 times sine theta would decrease until it reached 0. So vertically, the acceleration is a. It's a equals g. So when the vertical speed reaches 0, the time it took is the time we need to find for the horizontal component. So at what time the vertical component would reach 0? We will use formula v is equal to v0 plus at. The final speed is just 0. v0 is v0 times sine theta, yeah, sine theta. A is actually equal to negative g, because the g is pointing downward and the vertical speed is going upward. So this is positive. The acceleration is supposed to be negative. This is negative g, my bad. And then so that we can figure out t. So let's plug the number in. 0 is equal to v0 times sine theta minus gt. So that we can figure out t is equal to v0 times sine theta over g. Okay. We already figured out t. So how can we find, so using this equation, the displacement horizontally is just x equal to v0 horizontally times t. v0 horizontally is right here. We already figured it out. It's v0 times cosine theta. T is right here. We already figured out. It's v0 times sine theta over g. So let's plug these two in. It's equal to v0 times cosine theta times v0 times sine theta over g. Let's combine them and reform them, and then we can get the final answer, v0 squared times sine theta times cosine theta over g, which means D is the correct answer.